These calculations under energy quantization. The question is light of frequency 3.6 times 10 raised per minus 10 raised per 14 hertz is incident on a metal surface of work function 2.2 times 10 raised to minus 19 joule. We have to calculate the threshold frequency, energy of incident light, maximum kinetic energy of the photoelectron, and the stopping potential. You should remember what you understand by photoelectric effect is the process whereby a metal is heated and electron is emitted. But what are the terms that we need to know here? That is the threshold frequency and likewise the stopping potential. What do you mean by threshold frequency? Is referred to as the minimum frequency of an incident light needed to remove an electron from a metal surface. So what do you understand by stopping potential is reversed to as the maximum energy needed to free an electron from the electrostatic force of the what of the surface. Having known the two terms, the definition of these two terms here, and let's now calculate, let's find the threshold frequency. As we know that the photoelectric effect equation is E is equals to W plus KE. So this E is reversed to as energy of incident of radiation. This WE is that W is reversed to as work function. Work function is still reversed to as HF naught, while this E is HF. So there is a difference between this F and this F naught. This F here is normal frequency, while this F naught is reversed as what? As threshold frequency. And this K here is what reversed as what? As the kinetic energy. So here we have to calculate the threshold frequency here. So that is, we should recall that W is equals to HF naught. I've said earlier that our work function is equals to this. And in the question, work function has been given already. And we know that this H here, which is Planck constant, the value is constant. The value is 6.6 times 10 raised per what? 10 raised per minus 34 joule second. So we want to calculate F naught. This will be W is equals to HF naught. Work function here is 2.2 times 10 raised per minus 39 is equals to Planck constant is 6.6 times 10 raised per minus 34 multiplied by F naught. So we divide it by 6.6 times 10 raised per minus 34 divided by 6.6 times 10 raised per minus 34. When you have this cancel, you're going to have your F naught is equals to, this will give us 0.333 times 10 raised per minus 19 minus 34. You're going to have F naught is equals to 0.333 times 10 raised per minus 19 plus 34. As a result of that, that will give us, when you have that, you're going to have 3.33 times 10 raised per 14 hertz. That's the unit of our what? Of our threshold frequency. Since F naught is equals to 3.33 times 10 raised per 14 hertz, now question B says we should calculate the energy of incident light. So that is E is equals to HF. And to now find E equals to HF, F here is given, normal frequency is F, and this F is here. So the Planck constant has been given already as 6.6 per minus 34. We want to calculate this E. So this one will give us E is equals to H what is equals to HF, and E here is the energy incident of radiation. H is Planck constant, and this is frequency. We have to calculate energy, that is, you have to calculate this E. So this will give E is equals to, the Planck constant is 6.6 times 10 raised per minus 34. Normal frequency is given, which is 3.6 times 10 raised per 14. So when you multiply through, we're going to have 6.6. This will give us 6.6 multiplied by 3.6. So that will give us 23.76 times 10 raised per minus 34 plus 14. So this one will give us E is equals to 23.76 times 10 raised per minus 20. So as a result of that, we're going to have E is equals to 2.376 times 10 raised per minus 19. And because this energy is going to be in joule, so the next one is the maximum. Next one is the maximum kinetic energy of the photoelectron. And maximum kinetic energy is referred to as this Ke. Now from HF is equals to W plus Ke. So this W is referred to as work function, and we have known E already. So that is, we've calculated E from question number 2. The work function has been given initially from the question. We want to calculate the kinetic energy. So our HF is our E, which is what? 2.376 times 10 raised per minus 19 is equals to, the work function is 2.2 times 10 raised per minus 19, so plus Ke. So when you subtract this, you're going to have 2.376 times 10 raised per minus 19 minus 2.2 times 10 raised per minus 19 is equals to Ke. So here we're going to have 2.23, we're going to have 2.376 minus 2.2. So when you have that, you're going to have 0.176 times 10 raised per minus 90 is equals to Ke. So this will give us 1.76 times 10 raised per, so and this will give us minus 20 is equals to Ke. So this is now reversed to our what? Our kinetic energy, whereby the last one is reversed to us stopping potential here. So I've defined what stopping potential is before as the minimum energy. So stopping potential here. So from 1 EV is equals to 1 over 2 mv square. So this E is the charge of the electron. This V is reversed to as the stopping potential. This V here is velocity and M here is mass. So in order to now calculate the stopping potential, we're going to make V here the subject of the formula. So here we're going to have EV is equals to 1 over 2 mv square. So we divide through here by E. So we're going to have V is equals to 1 over 2 mv squared over E. So I will now substitute to the value that we have here as our M is concerned, that's the mass of the electron. The V, this V, don't forget that this V here is velocity, and this velocity here is has to do with the speed of light, that is 3 times 10 raised per 8 meter per second. So this E here is the charge of the electron. I will now calculate this. Let's call this one Vs, that is to know that is a what? It is stopping potential. So that's how we get the stopping potential. This M here is the mass of the electron, the value is constant. This V here is the speed, and the speed here will be the velocity of what? Of light. This E here is the charge of the electron. We now use that to calculate our stopping potential. So that's just it all about this calculation.